So like we said, the letter we can arrange this if you are arranging this in six places. And then the first one will be 6. We'll be left with 5. The 5 left will change each of the 1 on the 6 by 5. So it will be 5. So let's say we have 6. Now the next one we have 5 letters to fill the next space. So each of them are going to change by 5. Then the next one we have 4. So each of these is going to change. So you realize that it's going to be 6 times 5 times 4 times 3 times 2 times 1. And that is why if you have 6 numbers, 6 our term 6 will become 6 factorial. So that n will become n factorial. Now let's go to because this is how it should be, but of course we have some of the letters which are being the same. If they are the same, you must divide by that same number, the factorial of that same number, so that they will take out the same numbers repetition. Because if they are the same, we can't differentiate. We can't tell whether it's the same or not. So we divide. So in natural sense, this will be divided by the e and 2, so 2 factorial, the t and 2 by 2 factorial, and this will be the actual number. But for the purpose of the formula sake, let's look at the next one. Now the same letter, let's assume that we have 4 spaces to arrange it. Then the first one will have 6, next 5, 4, and 3. Okay. Now how did we get the answer for this? You realize that we can, to get the answer, let's say 6 choose or term 4 will become 6 factorial. 6 factorial will give us the total if we were arranging them in 6. But we have these 2 spaces not taken care of. Okay, so how can we get the same answer from this formula? You realize that we have to divide here by the last 2 factorial. Okay, good. And that will give us this. So if you look at this critically, you realize that this 6 is what we have here. How did we get 2 from this 4? You realize that we subtracted 4 from 6 to get this. So it means that if we have n, choose let's say term r, then we're going to have n factorial divided by, to get this, we subtract this one from this, and going to be n minus r factorial. And this becomes the general formula for permutation. Good. So this is the general formula for permutation. That is when we are not arranging up to the number. Okay, that's the general formula. Okay, so if this becomes n, if you put n here, then it becomes n minus n. 0 factorial is defined to be 1. Not 0. Remember, 0 factorial by definition we say it is 1. 1. Good. So that is permutation. So when you are dealing with permutation, first have the general formula n becomes n factorial over n minus r factorial. Now, if they are same elements, you must account for the same elements. So you divide the equation to get rid of the same element. You divide the equation by the same number. So let's say letter we have 2 here, 2 here. So for this formula, we would have divided by 2 factorial for e, and another t is also 2, divided by 2 factorial. Okay. So first get the general formula and then divide by same. So what I say is general formula divide by same factorial. Okay, and when you are divided by same factorial, then you are way to go. The third one that you should also look at when you come to combination, we'll bring that one. So permutation is actually equal to this. The general formula divide by same. If there are no same, then we don't need to divide. That is the formula. Now let's look at that for combination. So permutation comes with the words like arrange. Arrange. Okay, how many different forms? Okay, how many different forms? Then, of course, if they say how many different forms, it's a little confusing. But arrange is usually the word that you hear. So when you hear the word arrange, then we are talking about permutation. Now let's go to another one where the order, the way we arrange them does not matter, so far as they constitute one group. So that we will say that read whether you write, we'll say they are this and this are the same, they will be counted as one. In that case, we are talking about combination. Or what we usually use, the way we use is usually select or choose. Okay, so that is combination. Let's look at how we can derive the formula for combination. Now, use the symbol choose. So let's say n choose n. Now, what you do is to get the combination method, we can get that from the permutation. So first of all, if we know all the arrangement, that is for permutation, give us all the arrangement, possible arrangement. So n, n, r, that has given us all the arrangements. When it comes to combination, the only difference is, let's say read, and then this, the two are considered as one. So it means so far as they have the same words, if you change the order, we still count them as one. We will need to divide this by the words, the number of words which will have the same element within it. So we divide them by same word or same element, same element. Or let's say same group. Let me make it same group. Okay? Same group. So if they will belong to the same group, you have to divide by the same group. Now what do you mean by the same group? The same group will mean the number of words that you are arranging there. That is this is R. This the words, the number of spaces that you are doing the arrangement is the same. So that n choose R will become n pick R over what? R factorial. This can be rewritten as n choose R is giving us n factorial over n minus R factorial. All this divided by R factorial, and this will reduce to n factorial over n minus R factorial and then R factorial. And so this is the general formula for n choose R. That is the general formula. Right, so this is it. This is the general formula. But I've always said that let's look beyond that so that when you are solving questions, it becomes easier for you. So this is the general formula where we are taking into consideration permutation of all the numbers, and then we are also taking account of same group. Okay? Of course, if within this combination, select or choose a question, if they are same elements, we must divide by same element. So 1 over same element factorial. So in general sense, n choose R, these ones you won't see them in books, but I'm bringing them here for you to be able to grasp this so that when you are solving questions, you can get it well. So n choose R will become n factorial, n minus R factorial, and then R factorial, and then we divide by same element factorial. In actual sense, it is this. The permutation divided by same group factorial divided by same element factorial. This is the actual formula. And I prefer people will get this formula well. If you have this one, you are done. You can solve almost all the questions under combination. Alright, so that will bring us to the end. So when you have, let's say, if we have a letter again, as we are using as an example, we have two same E's, two same T's, okay? If we are arranging in 4 spaces, okay? So we can put the 4 spaces means that's 4, the group is 4. So the group will have changed a lot of arrangement, but it will constitute the same 4. So when it comes to combination, you have to divide by 4 factorial. If it is permutation, you don't need to divide by that because permutation, we consider each arrangement as separate, right? So that brings us to the end of combination and then permutation. Now, let's look beyond that. We can use combination to do some expansions. So combination to do some expansions. If we have a, b to the power 3, we can do some expansions. We have, if you want to get the coefficient, we have what we call the Pascal triangle. So 1, 1, 1, then we come to 1 plus 1 is 2, then put 1 here. 1 plus 2 is 3, 2 plus 1 is 3, then put 1 here. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, put 1 there. This is what we call the Pascal triangle. When you do this, it gives you the coefficient. It actually gives you the coefficient. So these are the coefficients. The Pascal triangle is the coefficient for any expansion. So to the power 3, this to the power, when you have your power 1, this to the power 2, this to the power 3. Okay. So to the power 3, this is our arrangement you're going to have. Okay. So this to the power 3. So you're going to have this kind of, these are going to be the coefficients for this expansion. Right. So there is a formula for if you don't want to use, when this one is, let's say, to the power 16, you can't use this kind of to get the coefficient. So there's a formula that takes care of both the exponents and then the arrangement, the order of these words. Okay, and that one we use the combination formula. So the first one is n, choose what n. Okay, then you have your let me give you the right. So let's say x plus y to the power n. That will given us, so this is 0. Okay. Now what happens is you have your x here. Okay. Your x will take the n part, and then your y will take this 0 part. Then go on. C again, n, come to 1. X takes n minus 1, and this is always equal to the y part. C again, n, choose 2. 2. So this you do until you get to n, choose n, x, n, your n, y, what, n, sorry, this is 1, 0. Okay, and this becomes the formula for this expansion. Okay, so if you have this, you can use this one to do your binomial expansion. So we have taken care of binomial expansion too. Now the last part that I want us to look at, so that we close the chapter for this discussion, is the around table arrangement for permutation. You see here, here. When it comes to around table arrangement for permutation, what you do is, if it is 6, if you have 6, the arrangement, if you have 6, say 6, the arrangement simply becomes what we call n minus 1 factorial will be the arrangement. No more arrangement. The permutation becomes n minus 1 factorial. That will give. So if you have, let's say, 6 people to arrange on a table, around a table, then the factorial is what? 6 minus 1 factorial is 5 factorial. The reason why we become so is you subtract one is you should assume one of them is fixed. And that the arrangement, if you change them, you can't tell which is the first one. So if you have one of them fixed, then you can say they are changing. With respect to that one, you can say they are changing, right? That you are changing arrangement. That is why, in terms of spacing, there's a freedom, what you call degree of freedom there. So 6 minus 1 gives you that degree. Then use that one too. Now, assuming that table can be flipped, if it can be flipped, then you need to divide this. You need to divide if it can be flipped over. Then the permutation will become n minus 1 factorial divided by 2. So you need to divide it by 2. it's important you keep this one too. That's arrangement around table. And this ends the discussion for permutation and then combination. The last part that we are looking at is to end this section is probability. So probability. Right, so probability we are looking at in simple terms. When you say probability, it's just like what you are interested in, the fraction of that. Okay, so you have a whole group or team which will have members. Okay, so the probability of the members can also be considered the events that you are interested in. The total group is the domain. Okay, then we have the element in it. So it's like set, we have the element in there, or the event in there. So this is the domain, okay, and that. So probability in simple terms for us to, I'll just make it is the same as fraction, or if we are using combination, permutation, or that is a combination, the same as number of ways of selecting, So let's say if I have 5, balls, 3 red and then 2 white. What's the probability of taking white? It's just a fraction of the white. So 2/5, that's a fraction. Okay, now you can also use the combination method too. The combination method will also mean 5 choose what? 2. So that will mean how many ways can you, the total number of ways that you can choose this one over the total. So 2 factorial over your 5 factorial. Number of ways of let's say selecting 5 choose what? 2, and then your 2, let me put it this way for you to get it well. So that would be ways of choosing the event over total ways of choosing the event from the total group. Okay, so let's say I have red. Ways of choosing this red over total ways of choosing red from the total. So among the red, let's say 2, I'm selecting 1. So 2, choose 1, and then the same one, selecting the same one from the group 5. That would be another expression for this. Okay, so let's say I have 5 reds, I'm supposed to choose 1. So 2, let's say I'm having a box. White, white, red, red, red. So in terms of fraction, if you just, what is it? In how many ways can I choose red? So red, the probability of red will be equal to 3/5. That's using fraction. Now if I'm using number of ways of choosing, then I can say that among the red, I have 3 reds. I'm supposed to choose 1. And then this same one, total number of ways of choosing 1 from the 5. So it's 5, choose 1. So that it will come back to the same answer. Okay, this is going to give you what your 3 factorial over what? 2 factorial, 1 factorial over so here I'm choosing 5, choose 1. Okay, so you have that one, 5 factorial over 1 minus 5 is 4 factorial and 1 factorial. So if you do that, you end up coming back to the same if you come back to the same answer like the fraction. That's what I mean. Right. So selecting it from its main group and then selecting it from the total group. That's what I mean. And that is how you can use this to get your answer. There are times that you have, let's say, a Venn diagram kind of thing. This intersecting, this not intersecting. U is the total, So see that here, this is A, this is B. When you have this one, you see they are mutually inclusive. They share, they are mutually inclusive, they share. But here they are mutually exclusive, they don't share. So where they share, if you want to find the probability of A union B, putting them together, will be probability of A plus probability of B minus probability of A intersection B. Why do we say so? So the total, these are the total groups for this one. So the probability of this one plus the probability of this one, this will be, total probability must always be equal to 1. So probability of this one plus probability of this one must be equal to 1. But remember they are sharing a region. So when you add them, when you add this one and then you add this one, you have added this portion twice. That is why we subtract this portion from it. That's why it's a subtraction. So for this is mutually what? Inclusive. Where they share, they are dependent. Then you have to subtract. But if they are exclusive, this is A, this is B, then probability of A union B will just be probability of A plus probability of B. And this must be equal to 1. This must be equal to 1. Total probability must be equal to 1. And that is how you can use this formula too. So from this, sometimes when you ask to find this, you can just move this one and get it. Alright. So remember, total probability is 1. Now, you must remember that in probability, you must look at the questions from this angle. Always, you have an event like that, okay? This day, okay. Within this is an action. I'll call that action, and these are the events in it, or the elements in it. Okay, within one action, total probability must be 1. So the probability of this one, A or B or C, must equal to 1. So all in probability sense is plus. So A plus B plus C should be equal to 1. If they have common intersection, then you subtract the intersection. After adding, then you subtract the intersection. After adding, then you subtract the intersection. Okay, so after adding of them, you must subtract the intersection so that you don't end up doubling then that is it. So that's all. Now let's say this is for an action. So for an action, the elements or the events, they are joined by all. So this is action 1. Now let's say there's another action 2. Action 2. For action 2, okay, action 2, it has its elements or events. So this is the sample space. The sample space, that's the total, okay. Action 2, we also have A plus B plus C plus D. If they share common ones, if they have intersections, you subtract the intersections. They must also be equal to 1. Now sometimes you can ask you, what's the probability of action 1 happening and then action 2 happening? So action 1 is action 1 happening and then action 2 happening. It means when you are moving from one action to the next action, they are joined by end. And the end in probability is multiplication. So if this has happened, and then they are saying this, what's the probability that this one has happened and this one has happened? So find the probability of this, and the end you multiply by the probability of the next one, and then that will give you an answer. But remember that when you do the end for all, let's say this and this and that, this and that, when you do all of them, considering the two actions together, their total probability must also be 1. Anytime you consider everything together, it must be 1. So for all this, probability is equal to 1. That is for this action. For this action, probability is equal to 1. But if I say this and that, you have to multiply this probability by this probability. And then if we are looking at the two together, their total probability will also be equal to 1. Okay, so that is important. So always try as much as possible to get the action. That is, you have been asked, either pick or choose. That is the action, or select. So that's the action. If there's another action, separate it. That's another action. So that when you are joining them, you know it is n sometimes. If it is within the same action, it is all, so it's plus. If within the same action, the groups share common ones, you must always, after adding, you must subtract the intersection, where the number of commons between them, you must subtract it so that you don't end up doubling them addition, right? So that, and then the last part is probability of, let's say, A, given that B has occurred. So let's say we have this intersection, this is A. So there's it A and B. What is the probability of A given that B has occurred? So what happens here is that they are saying that this probability, from this probability means B has occurred. When B has occurred, what is the probability of finding A in B? The only way, if B has occurred, the probability of finding A is this portion. So you see that probability of finding A will become what? Probability of A intersection B over probability of what? B. That's the formula. So this is mathematical sense. It means probability of A given that B has occurred. So B has occurred, has happened. So when B has occurred, it means this portion is out. Now we are considering B. So within B, what is the probability that B, A part of A occurred? So it will be this portion over the total B. So this portion over that. And that's the probability set. When you get this sense, up to this level, you should be able to handle the probability questions. So I think at this point, we have had a very fruitful discussion. We'll end this section here, and then we'll continue the last part of the mathematics, which is going to be statistics. And I hope you enjoy that part of the discussion, because that is where I love to use the estimate, and then we are able to tackle real life situations and then approximate for certain events. Thank you. So we'll end here and then continue with the next section, which is statistics. We'll start with the basic statistics to the advanced statistics, but we'll be brief and straight to the point so that to make your learning very fruitful.